Hello everyone. In first topic, that is hydrogen atom, we have studied the quantum theory of hydrogen atom and angular momentum. Now the next topic in this unit is electron spin. The electron spin is the concept which can be explained in order to explain the fine structure of spectral lines and anomalous Zeeman effect. And to explain the fine structure which is exhibited by the atoms, so the spin concept is considered, and as the before the spin, it is considered that the electrons is revolving around the nucleus, just like the earth revolve around the sun, and the concept is then put forward that similarly earth revolve around the sun, it also spin about its axis. So in case of electrons, similarly the electrons is also spin the same way like the earth, and the electrons spin about its own axis. This concept was first introduced by the Goldsmith and Uhlenbeck in 1925. And according to this concept, what is the electron spin concept? When an electron moves around the nucleus in an atom, it also spin about its own axis with some intrinsic angular momentum that is independent of any angular momentum that it might have. And the magnetic moment arising due to spin react in quantized fashion with the magnetic moment due to the orbital motion of electron, so that the spin can be either parallel or anti-parallel to the orbital angular momentum. And we can derive the spin angular momentum of a spin of electron, that is S equal to S star H cross, and the S star is nothing but the under root of S plus 1, where S is the spin quantum number and that is having the fixed value. So that if we take spin of this, so S equal to half, so angular spin angular momentum, its fixed value is under root of 3 by 2 H cross. So the concept of this spin and its relativistic quantum mechanics. Another concept which can be followed by this spin of electrons, that is space quantization of electron spin. Now before that we have seen the space quantization in angular momentum for L, and here is the same the spin quantization for the spinning. So the magnetic quantum number for spin electron is ms, and the value of ms will take minus s to plus s, means s is always half, so minus half to plus half. In case of angular momentum, orbital angular momentum, the magnetic quantum number which will take the values from minus L to plus L. Now similarly we can take these values for the spin quantum number, and if we draw the spin space quantization diagram, now we will take the vertical axis y axis, which is the z component of spin angular momentum, and there are two values of magnetic spin quantum ms, that is plus half and minus half. So plus half h cross, that is value of s sz, and minus half h cross, it is another values, because ms equal to plus half and minus half. Now there are two orientation of spin angular momentum s. From that O point there is one and there is another, so that is there is some angle, cosine angle, which can represent this the orientation. So the orientation of spin angular momentum in the space while the electron is spinning, that is known as spin condition. Now the spin magnetic moment and its magnetic ratio for the spinning electron. As the electron orbiting the similar way, it also spin about its own axis. So because of this spinning, that spinning electron behave like a tiny magnets. It poses the angular it poses the current, because of the electron is negatively charged, and because of spinning it produces the current. And we know that the product of current into that area, that is nothing but the magnetic moment. So the similar formula we can derive for the spin angular momentum. Now the only is the factor 2 will be appears, because of to maintain in order to obtain agreement with the experiment. So with in order to make the experimental agreement, so we have to add this 2. So what is the value of spin magnetic moment mu s, which is equal to minus 2 e h cross upon twice m into a star. And similarly we know that whenever any electrons having the magnetic moment, and if we apply the magnetic field, so the product of spin